This is Møller Nielsen from Java Code Geeks, and I'm going to teach you how to write clean, efficient Java code using SQL. If you have an application, you probably also have the need to store data, and then a relational database could be the answer. In order to give commands to this database, you need to understand SQL, Structured Query Language. Complementary to this video, there will be related articles and resources in the description below. Feel free to visit Java Code Geeks to stay up to date with Java-related stuff. If you liked this video, please take the time to like, subscribe, and hit that notification bell so you know when the next video is up. Now, without any further ado, let's get started. Before we start writing SQL, you need to understand what a database is. A database is a place where you can store tables. And tables is something that you can look at just like you look at a spreadsheet. So in this situation right here, I have started up a LibreOffice Calc spreadsheet. And in here, I'm going to create a table and I'm going to create some columns. And it's exactly the same thing that we need to do in our database in just a couple of minutes. First of all, when we're dealing with a table and a relational database, we need something unique. So we always need an ID column. So the first column, I'm going to name that ID. Then the next thing, let's say that this is a spaceship table. So that means that the name of the table is spaceship. Then I would actually like to have a captain to my spaceship, in my spaceship. Then I would like to have an amount of fuel left. This could be in liters, maybe thousands of liters of fuel. And then the last thing I would like is maybe to see what kind of shape is this spaceship. It could also be a model type, of course. And then these are called the columns or the fields. So these are fields, the four columns that you see right here. And these columns, these fields, they have a type. So the ID it would have the type of integer, for instance, and then it would have then the number would then increase one at a time for each row in our table. So this is called a row. Every time we have a new entry into a table, that is the same as a row. And the captain, this could be a varchar, that means a string, and maybe the captain right here is Mike. The fuel is maybe 44 thousands of liters of spacecraft fuel. And then the shape could be round for this spaceship right here. Then we could have another captain, which name is could be Susan. And then we have a fuel percentage of 55,000 liters. And this shape right here, it could be a pyramid. And so on, so on. We can make another one, John. And 22,000 liters, and again this could also be round, and this could be Jane, and again this could be, then we give some kind of fuel amount that is left, and then this could be a pyramid shaped spaceship. In this situation right here, I typed in the name for the captain, but maybe we have the captain in another table, and this is where the relations come in between tables. So let's say that I'll now create a new table right here named captain. So here again I have ID as the first column, and then we could have a name as the second column. Then we could have years of experience or experience in years, and then we can have maybe a number of crashes. And again here we will just start with 1, and then we will just increment by 1 for each captain that we actually have. So then here I would have Mike, and then I would have experience of 3 years of flying with spaceships, and maybe I had 2 crashes. And the same with Susan, and the same with experience. We'll just say 2 years, maybe only 1 crash. John, and then maybe 10 years of experience, and maybe some more crashes, etc., etc. I'm just filling out some dummy data right here. And now instead of having the captain name up here, maybe we want a reference to the captain by ID. So that instead of having a captain right here, now I'll call this captain ID. And then I will create a relation between these two tables by actually mentioning the captain ID right here. So maybe it is Susan that flies the first spaceship, then I will type 2 right here. Maybe a captain can actually have more than one spaceship, so maybe Susan is also flying spaceship 2. And then we have the third spaceship, this could be Mike, and then the fourth spaceship could then be Jane. And as you can see here, by using the ID instead of typing in the name, that means that if I have some metadata for Mike or for one of the captains, then I only need to change it one place in the captain table. And then of course, this information does not need to be in each row of the spaceship. So this is how usually you would organize a database. You would create relations between tables, and then you would set the reference by IDs between these tables right here, just like I did. A good convention, if you don't have one yourself, is always to name the ID, and then you can create the relation or the reference ID column. Then you can name that the name of the table, and then underscore ID. If you don't have a better naming convention yourself, some companies, they have naming conventions for this. So this, when you think about tables, then just think about a spreadsheet. Now, for this presentation right here, I am using Docker to actually get access to a database. If you have a Postgres database installed somewhere, of course you can use that, or you can also, of course, use any other database like MySQL. I would recommend you to use MySQL or Postgres, and personally, I prefer Postgres if you're new to SQL. The reason why I prefer Postgres over MySQL is that Postgres is giving more consequence errors than MySQL. MySQL actually tends to accept a lot of errors and actually tries to guess and make something that actually works out of it. The benefit with that is that then you would not get as many errors in the beginning, but the downside is that the things you insert into a database could not be what you actually meant to insert. If you know Docker, then you can create a Docker file like I've done right here. You can set up a Docker Compose file with services and then my Postgres, and then use the image Postgres latest. And then you need to give a username for your database, a password for your database, and also which default database should be used. I would also recommend that you start up the adminer. Application. This is a web interface that you can use to access your database, and the image name is adminer :latest, and of course the description for this is present at Docker Hub. If you don't know how to start it up, and if you want to see which options you have, you just need to be mindful that you map out the ports so you can reach it on localhost, and then the ports right here. The same with the web port right here, so that means that then you can reach adminer in a browser on port 8080. But this is Docker related, all of this. So you need to have a database, of course, in order to write SQL. And I've already started my database by writing Docker Compose up. And as you can see right here, the database system is ready to accept any connection. So I am good to go. I am using latest and greatest IntelliJ right now. I'm using IntelliJ Ultimate. You can also use IntelliJ, the free version, and which is also just as fine. I am connecting to the database by pressing View and then Database, and then under Tools, and then I'll find the database view. In my situation, it's actually also on the right side, so I can just press the tab in the right side, and then I will create a new connection by pressing New right here. And then data source, and then I will choose the type of database that I have. I have my Postgres SQL, so that's the one I choose. And as you can see right here, there's a lot of other databases to choose between. And if you don't have the driver installed, actually IntelliJ will help you to install that driver. I'm choosing Postgres right here. Then I will type in the name, and here this is just a logical name, so you can actually remember it. You can call it demo or something like that. And then you need to give a localhost and then the default port. Yes, that's correct. Then the username in this situation here was Mike, and it was Mike. What is it? ABC1234. ABCD1234. I'm not going to press OK because I've already created this data source right here, so I'm going to cancel it. But in your situation, you would just press OK. Now I see the option. Now I have my database in the right side right here, and I can see I have two databases in it already. The default database is named Postgres, and that is fine for you to use that. So now let us get started with SQL structured query language. The first thing we need to do when we have a database is that we want to create a table. So I have created this SQL file right here, and again, I would recommend that you actually create an SQL file whenever you want to create an SQL, and because it's easier to change and to fix errors in this SQL right here, and IntelliJ will help you with any errors that you have. There's this tab right here. This is the dialect, where you can choose which dialect that you want to use, because there are differences in the SQL dialect between the different databases. This means that if you write an SQL for Postgres, you cannot be sure that it also works for MySQL or for Microsoft SQL servers or for the Oracle database. This means that the SQL is specific to the type of database, and that's why we have to choose the SQL dialect from this drop down here before IntelliJ can help us with code completion and help us with resolving errors. The first thing I want to do, I want to drop the spaceship table if it already exists. The reason why I want to do that is that I don't want a table where I already have some data in it. I want to have a fresh table, and then I create a table afterwards if it does not exist. If it already exists, then I do not want to create the spaceship table. Of course, I'm deleting it right here, so I know that it does not exist in the next line. But this is just to show you that you can actually include something like this, if not exist, just to give a bit of logic, to give a bit, to make your SQLs a little bit intelligent. And then we name the table, and in this situation right here, I name the table spaceship, and then I start with a round bracket. And what I have in a round bracket right here is the columns, the fields. And the first field I have is ID. And if you want the ID to be incremented automatically, then you would give it the type serial. If you give it the type integer, for instance, then it would not, the table would not automatically increment the ID. You would actually have to handle this yourself. So to make it easy, right, you choose serial for all of your ID columns. Then I give it a constraint primary key. What this does actually is that it tells the table that this needs to be unique. This also enables us to create relations between other tables and this table by using the ID. So this tells the database and the table that this is a primary key and therefore unique. That means I cannot have two spaceships with the ID equal to 1, for instance. And the cool thing about this is, as we will see very soon, that if I want to select a spaceship with a certain specific spaceship, then I can choose it by, then I can select it by ID if that is what I want. And I can also update the spaceship table, and I can delete a row from the spaceship table by using the ID as in the criteria area. Then we have the captain right here, and this is a varchar 14. That means that the name can maximum be 14 characters long. Of course, we could also set this up to 250, so we are sure that even though we have long names, then we would not get an error when we try to insert data. Then I have this constraint right here, which is not null. That means that I cannot put null values in the captain in the captain column. Sometimes you would have you would allow the value to be null. For instance, if no captain has been assigned to the spaceship yet, then you could actually have a situation where you want the value to be null instead. Then I have the fuel number of 1,000 liters in the spaceship, and this type right here is integer. And if you don't know which type to choose, then you can you can get some help from IntelliJ by pressing Control Space, and then you will actually get the types. And you can get the types right here. We have different integers, and we also have, let's say that we want the floats, and we can also get the varchar. If I don't remember that, we can get a bit, etc., etc. So we get a lot of help with the code completion from IntelliJ. Of course, there's a lot of other integrated development environments, IDEs, which of course supports SQL and databases. Then we have the shape right here, and that is a varchar 255, that is like round, etc. And I don't think this should be null actually either. So I'll just add not null as a constraint to this column right here. Let us try to run this so I get my table. So I'll right click and then I'll say run right here. So, and then the first question that I'm given is which data source should we run this SQL against? I only have one Postgres right now, so I'll just double click on that. Then I'll press 1, and then we'll see what happens. It connects to the PostSQL database, and there are no errors, or else I could see that in the output right here. And we can see there's a summary right here. 2 out of 2 statements were executed in 68 milliseconds. Cool, that looks good. So let me go to Postgres and then to the public schema. This is called a schema. You can have different schemas. That's the way you can actually organize your tables. So it's like a division, or yeah, if you want to divide your tables into different groups, then you can use something called a schema. I'm not going to use any schemas in this demonstration right here. That means that the public schema will be used automatically. And right here we can see I have a table named spaceship, and in the spaceship right here it has 4 columns: the ID, the captain, the fuel, and the shape right here. I can also double click my table right here, and then IntelliJ will show me all of the rows, and right now there are no rows inside this table right here. So let me close that view again. The next thing I want to do is I actually want to insert some data into my spaceship right here, and let me just minimize this the right box right there. So now we can see what's happening. So first we write insert into. That is the first part of the insert syntax. Then we need to give the name of the table. In this situation, it is spaceship. Then a round bracket, and then we need to name all of the columns that we need to want to give. We are leaving out ID because the ID will be incremented automatically and handled automatically by the table, because we chose the serial type for the ID. Then we need to give the values, and then again a round bracket, and then we give one value at a time, Susan, because it matches the location of the captain field, and this is the number of thousands of liters of fuel. And then we have the type out here, and then we have a lot of dummy data right here. So all of these right here are different statements. So that we actually end each statement with a semicolon, and then a new statement can start. We can run all of these 7 statements right here by right-clicking and then say run again. And again, we need to choose the data source. If you have already chosen it once, then you don't need to do it again. So we also have the execute, which is right here. Then we can choose which statement to execute. We can press, let me just see right here. We actually got the summary right here. 7 out of 7 statements executed in 23 milliseconds. That is awesome. So now we have some rows. We might have some rows in our table or not. We do not know yet. So let us try to create a select query against our database. And all of these statements that we're creating right now, these are called SQLs, structured query language. And it does not matter which type of content there is in SQL. They're all named SQLs. Here we have select star from spaceship. Instead of star, we could also have mentioned all of the columns. But if I just want all of the columns, then I can choose select star. So let us just start with that. I'm marking the text right there, and then I right click, and then I can choose execute, or press Control Enter. And then I can create a new session, a new database session against the database, and then I get the result right here in the bottom of the screen. So in this situation, it was only one SQL that was actually executed. That was the area that I marked right here. So that is another way to run inside IntelliJ. And as you can see right here, we have all of our IDs on the left side, and we have not typed those in from 1 to 7. And then we have all of our captains like Susan, Mike, John, Jane, Paula, Ophelia, and Oscar. And we have some fuel percentages. We also have some shapes. Let us say that we actually want to group, and we want to sum up the fuel per per shape. It is very normal that when you have some data, you want to aggregate, as it's called, aggregate the data and group the data, and so use computations like the sum or average function, like we do right here. When you use if you use an aggregate like this, like sum, and if you also want to group to sum it up per shape, then you need to mention the shape in the group by part of your SQL statement right here. And this is actually one SQL statement, because you can see I have semicolon and end right here. I just like to have it on multiple lines, because then it's easier to read. So we have our from part right here. We have our group by right here. And of course, if I want to group by multiple columns, then I could do that by just mentioning the columns up here. And then of course I also had to group by in the bottom right here by separating the columns with a comma right here. Now let us try to run this and actually see what happens. So Control enter, that's what I pressed right there, and then this small box comes up, and then I can choose which statement I want to execute, and then I see the result in the bottom right here. So we have the saucer. There's a sum of fuel with 20. The box has a sum of 115, and the round shape has a sum of fuel with 110. Let me just execute this statement again, just to make sure that it actually looks right. Yes, it actually looks like right. I have 115. If I sum up just by just in my head, then I can actually see it gives 115, and this gives 110, like this. So that is how to group by. Now let us try to see how can we update some data if we are not satisfied with the data. Maybe we want to set the fuel to 100, where the fuel is less than 50. Then this is exactly what we do. First we mention update. So this is an update statement. Then we need to mention the name of the table. Then we need to use the set. Then we use the set, which column, which field is it that we want to set. And then we mention the name of the column, and then what do we want to set it to. In this situation, 100. And in which circumstances do we want to set it to 100? We want to set it where the fuel level is less than 50. So let me just press Control Enter right here. Then I'll run this again in a new session. And we can see that 5 rows were affected, and it only took 6 milliseconds. Let me go back now and select all of the spaceships by marking like this, and then I'll press Control Enter. And here we can see that now we have 100 in the fuel, where before it was below 50. So this is how we update data in our tables. Another thing we can do is that we can delete from our table. Let's say that I want to delete all of the spaceships where the captain is like when it starts with M. Then I can do it like this with M and then a percentage sign. It is a little bit more fun to use J, because I can see that we have 2 J's right here. We have John and Jane. So let me try to delete from the spaceship where the captain like J, where it starts with J. Enter, and then I'll run in the new session again. And 2 rows affected in 6 milliseconds. Okay, I'll go back to my select spaceship right here, and then we will see. I do not have any spaceships where the captain name starts with J any longer. They have been deleted. And we can also see now there are gaps in the IDs. We have 1, 2, 3, and 4 are gone because we just deleted them. Still, if I create a new row, then the next ID would still be 8. The IDs will not be reused, even though there are gaps in the number series. Okay, so these are the basic statements. We have create table, we have insert into a table, we have select from table, we have update table, we have delete from table. The next thing is the relations. Let me just close all of these right here, all of these tabs. So now we want to create a relation. That means that we want to have 2 tables. I have named this real spaceship and real captain just so the name of these tables actually are different than the simple example where we did not have any relations. So I've named this real spaceship, real captain, and again I'm dropping the tables if they already exist. Then I'm creating them again if they do not exist, and again ID, name, experience, number of crashes. This is the captain's table, as we can see right here. Then we have create table, if not exists, real spaceship right here. And here we have the ID, which is unique again. Then we have the captain ID, which in this situation cannot be null. And this is the reference to the captain. So instead of having the name inside of the spaceship table, then we can now have a reference to the captain where we can have a lot of other information about the captain. So here we have the fuel, we have a shape, and then I'm creating a constraint. I'm saying that the captain ID references the real captain table over here by the column ID. So that actually means that the captain ID right here, when I insert a new row, then this ID right here, it needs to exist in the captain table. So this is a constraint that I'm adding right here. I'm creating a relation between two tables, and that is why it is called a relational database. Let us execute this SQL right here. Right click, and then we say run. And then we choose the data source again and press run. And it looks like it works because we have 4 out of 4 statements executed and there are no errors right here. Then we have the real captain right here. So that then now we can actually create a captain. First, we create a captain right here, which we say insert into real captain, and then we mention all of the columns. Then we mention the values, Mike, 3 and 2. And then we create another captain right here, which is Susan, 6 years of experience and 1 crash. And after we have done that, then we create 2 spaceships that actually points to those to those IDs that we just created. That means that we will say value 1, that is the ID of the spaceship, of the captain. And then we have the other ID right here, that is Susan, which will get ID 2. So now let us try to run this SQL right here by right-clicking and say run. We choose an SQL again right here. We say run. Oh, I forgot to double-click. I'll double-click the source and then I'll press run like that. Now I can see 4 out of 4 statements executed in 10 milliseconds. And now we can actually select our data. Now our select statement, of course, we could just select from one table if we want to. I could just select my captain if I want to do that. Here, this is my captain table. I have Mike, Susan, and some years of experience and some IDs. I can also select my spaceship like that. Control Enter. That's what I press to get that little box up there. And again here now I can see the content of my spaceship in the bottom. But what if I want data from both my spaceship and my captain's table? Then I need to join them. So then I will create a select star from real spaceship ship. So that means that this is the table where I start. I start in the spaceship table, and then I join the spaceship table on. I join it with the real captain table. And this is an alias. You can see I have an alias right here, which is ship. That means that I can actually refer to real spaceship by using this alias ship right here. And this means that I don't need to write as much when I refer to it in my condition area right here. And then I say RC for real captain. I could also just say like cap, something like that. So now I've actually cat. So now I've created an alias named cat. And then I need to say which column should we join these 2 tables on. And we want to join the ship captain ID with the cat.id. And again, this is just an alias, and that's what I showed by just changing it to capt. Right now, it's a bit shorter to write capt than real captain, for instance, and it's a bit shorter to write ship than real spaceship. Let us try to run this command right here. Now we can see, we get all of the columns on the same row because we have joined the two tables together. Awesome. These are the basics of SQL and how to start doing stuff inside a database. Of course, there are much more to it. There are a lot of commands. The SQL can easily be very, very complex, especially if you have 6, 7, 8 tables that you want to that you want to join together. Then of course your SQL will be much more complex, and it can get very, very difficult to actually read SQL. But if I can give you a tip and trick, then it is that actually first of all start from the top, and then you will say, okay, the first spaceship, the first table that is mentioned, that is the table where you start from, and from there then you can see how it's joined. And another thing you can use is the database view inside IntelliJ like this. And as I said before, you can just use the community edition, which is free. Of course, you can also use the ultimate version, which I have right here. Then here we can actually see which tables I have. I have an overview. There's also something called views. That is if you don't want to run this SQL every time, then you can actually create a view based on this SQL, and then you can just select from that. That is also an option if you're dealing with very complex SQLs. Then it makes it easier for whoever wants to extract data from your database to use the views instead of using these long SQLs. Here we have the real captain, the real spaceship right here, and we have the real captain right there. We can see we have some keys right here. We have some foreign keys that we defined. We also have some indexes. Another thing that is very important, if it takes a long time to extract the data when you extract data from your database or from your tables, then it's probably because your SQL is not matching the indexes. If you do not have the correct indexes, then the database actually has to go through each row one by one when you need to find something. But if you have indexes, for instance, on the columns that you are using in the where part of your select statement, then it goes much faster. With indexes, it takes a little bit longer to insert rows than it would without indexes, but it is much faster when you need to select the data again. So there's a little bit overhead when you insert into a table, but you will get that again many times, because usually you select much more, many more times that you would actually insert data. Another little trick I can give you is that instead of updating data inside a table, then it's actually much faster to delete and to insert. It's very fast to delete and insert, but it can be slow, at least, to update rows inside a table. And of course not if your indexes are created correctly. If your indexes are correct, then it does not take long. But if your indexes are not, then usually it is faster to delete rows and insert rows than it is to update rows. But that's about performance. This demonstration was the basics about SQL. I hope you enjoyed this video. If you did, then please take the time to like, subscribe, and hit that notification bell, because we have a lot of cool stuff coming up. Bye.